In the last section of this course, we developed a basic web page using tables and inline style attributes. You might recall we styled table borders, fonts, headings, and background colors. You may have noticed this process was quite inefficient. We repetitively had to keep placing the same style attributes over and over again for any document element that we wanted to apply a style to. For example, if we wanted to change the font color and typeface of text in 3 separate areas, we would need to change the font face and color attribute in each instance. This made the process inefficient and the code quite lengthy. Secondly, when we put the web page together, we put the contents in tables using rows and columns. This helped make the page look organized, but there really wasn't too much flexibility in the positioning of our content. We were more or less limited to left, center, or right alignment attributes. More so, we were unable to stack multiple objects on top of one another. For example, if we inserted an image into a table cell, we could not place any other object underneath or on top of that image, a concept known as layering. In this section of the course, we're going to explore the world of CSS, cascading style sheets. CSS helps eliminate all of these issues and makes the development process much more flexible, efficient, and browser-friendly. Once you start developing sites using CSS, you'll likely never use table-based website layouts again. This doesn't mean you'll never use tables. Tables are still an excellent way to lay out tabular data, but you won't be using them for layout and styling your website elements and content. So what exactly is CSS? Think of a cascading style sheet as a list of style rules that you can refer to at any time to format your text, images, tables, and just about any other object on your web page. These style rules are entirely user-defined, meaning you make them based on your needs. They are highly customizable and easy to use. Furthermore, you can link each page on your website to a single style sheet and update hundreds or even thousands of pages simultaneously. At this time, you might be wondering what a cascading style sheet looks like. Well, we touched on it in the beginning of the last section. If you recall, we introduced the style tags and created a single style rule to define the web page text color. If you've forgotten, then don't worry. We'll be working extensively with style sheets during this section. The syntax for CSS is different than HTML markup and consists of 3 parts: a selector, a property, and a value. The selector is the HTML element that you want to apply the style to. Let's take a look at an example. Open the file in your Downloads folder corresponding to this lecture. With the file open, let's preview it in our web browser to see what the original looks like. We can see that there are 3 headings and 3 paragraphs. Now let's create a style sheet contained within our head tag. Let's create a style rule that changes the background color of our web page to pink. For this, we will need to create the following style rule inside of our style sheet, so in between our open and close style tag. In this case, the body is the selector and the property is the background. Once you've inserted the style rule, save your document and preview it in your web browser. You will notice the page's background is now pink. Each selector can have multiple properties. For example, if you wanted to change both the color of the background and the default font for the web page to Arial, the CSS style rule would now look like this. Let's save our page, and we'll refresh the contents in our web browser, and we can now see that all the font on the page has changed to Arial. If you only wanted to apply another rule to certain selectors, you can do that as follows. Let's say we wanted to change all the headers, all the H1 tags in our document to a different font color and a different font family. In this case, any block of text within H1 tags will have the color red and the font family Georgia. So let's go ahead and add the H1 tag around our first heading, heading 1. So I'll start with the open H1 tag and the close H1 tag. Now let's go ahead and save and take a look in our browser. We can see that the heading is now much larger and a different color. The font face is also different. So just as we intended. Selectors can also be combined. So say for example, not only did we want to change the H1 headers to this font and color, we also wanted to do the same for H2, H3, and H4. So let's go ahead and apply the H2 tags to our second heading. And the H3 tag to our third heading. Now we'll save our file. And there it is. Now we can see that that style rule was applied to heading 1, 2, and 3. There are three types of CSS styles: internal, inline, and external styles. This HTML page illustrates an example of an internal style sheet and inline styles. An internal style sheet simply means that the style sheet is contained in the same HTML document in which the styles are used. Here, we've defined a style sheet in between our head tags, with three rules that will format the body, the header 1 tags, and the paragraph elements. This is an example of an internal style sheet. We can easily convert this into an external style sheet by placing our style rules in a CSS file and linking to it. To do so, cut the style rules out and delete the style tags. Now create a new file and paste the style rules into it. Now save this file as mystyles.css. You can use any name you want, that's just an example. Make sure that the extension is a .css file, otherwise this will not work. Now I'm going to switch back to the original file, and we're going to link to our external style sheet using this line of code. We can confirm that it worked by previewing the file in our web browser. And you can see that all the styles are still applied. In addition to internal and external style sheets, we also have inline CSS. With inline CSS, the style rules are added directly inside the element. For example, here we have a paragraph element with two inline rules. Style is equal color blue and font size 35. We can see in our web browser that the style rules have been applied to this paragraph of text. The text size is 35 pixels and the color is blue. Using inline rules is normally not a good practice because it's inefficient. If we used inline rules on all our pages, we would need to individually open each one and edit the rule. Inline rules also cause unnecessary repetition and increase the length of the HTML code. When possible, use external style sheets. When working with colors in CSS, it's important to know that all colors displayed on the screen are produced by combining red, green, and blue, also known as the RGB color spectrum. We can set colors in CSS using color names, RGB color codes, or hexadecimal values. This HTML document provides an example of all three. Our style sheet has three rules that will apply font coloring to any H1, H2, and H3 elements. The H1 style rule uses a color name, in this case red. The H2 style rule uses a hexadecimal code which represents light blue. The H3 style rule uses an RGB color code that represents a light purple color. We've referenced each of these rules in our HTML body, so H1, H2, and H3. We can see in our web browser, this is the end result. We can see that each style rule has been successfully applied. So H1 is red, H2 is light blue, and H3 is light purple. In order to get color codes and hexadecimal values, we can use a number of free online tools. Colorpicker.com is one such example. Here, we can browse through a color palette and retrieve the corresponding code values. If I wanted the code of this green, you simply click on it and you can see the hexadecimal value here, and you can see the corresponding RGB values here. And you can do that with any color in the spectrum. The class selector allows you to apply specific styles to an HTML element from CSS rules defined in your style sheet. Think of it as setting up a catalog of different styles in your style sheet and referencing these styles when you need to apply them to your HTML elements. Let's take a look at an example. In order to create a class, we need to define it in our sheet. We'll go ahead and create one class. We'll call this class blue bold text. This is the syntax for defining a class. And you'll notice that the class begins with a period, followed by the class name, and you can give it any name you like. We'll create a couple of other classes that we'll be using as well. So for the class definitions, we have a large font size, the color is green, and this text will be bold. And just one more class. This class will underline any text we apply it to. So we now have 3 classes created. Now let's apply one of the classes to the text contained in this column. Applying a class is easy. We just need to call the class by its name. And so for this block of text, we'll apply the blue bold text class. Now let's go ahead and save our file and preview it just to make sure that it worked. And so you can see that this class, the class we created, has now been applied to all the text in the column we'd applied the class to. Now say for example we wanted to apply a different class to just these 2 words, lorem ipsum. In order to do that, we need to use the span tags. So we create open a span tag, and a span can have a class as well. So for this, we'll use the large green text class. Just make sure there's no spelling mistakes. And we need to close the span tag. Okay, so you can use the span tags when there's no inline element to apply the class to. So let's save our file and preview it. So now we have these two words that are a different class than the text, than the remaining text in that paragraph. Now say for example, in addition to the large green text class, we also want to apply the underline class. Well, you just make a space and type the second class you want to apply. Now save your file, and we'll refresh our document, and we can see that the underline class has now been applied to this text as well. Divs are yet another very important part of CSS development and are represented by the div tags. In order to understand the function of a div, let's refer back to the web page we developed using tables. When we created the web page, all the content, including text and images, were nested in table cells. As we determined, we did not have much flexibility in the positioning of these objects within the cell, or the table itself for that matter. Divs are similar to table cells in that they contain content such as text, images, or media objects. The key difference is that divs offer a much higher degree of customization in formatting and positioning. This includes things like rounded corners, transparency, layering, and complete flexibility in positioning down to the pixel. Before we begin this tutorial, please open your text editor and set up your basic HTML page structure as shown. Save the file as div.html on your computer. Now let's go ahead and create a div in our document and fill it in with some basic text content. We will create the div in between our open and close body tags. The open div tag requires a closing div tag. The content in between the opening and closing div tag will be displayed in your browser's content area. Now let's go ahead and save this file and preview this in our web browser. So here we can see the line of text we inputted into the div. You can think of it as a line of text contained within a single table cell. If this were a table, the table would have one column and one row, equating to one cell. We haven't done any CSS formatting to this div, and we'll be exploring that in the next lecture. Now that we've created our first div, we can explore CSS declarations that allow us to customize the look and positioning of our div. The first item of discussion is CSS IDs. CSS IDs are similar to classes. They are defined in your style sheet and referenced in your HTML elements. The primary difference is that once an ID has been referenced in an HTML element, it cannot be used again within the same HTML file. You might recall that when we created classes, we could use that class as many times as we needed for multiple HTML elements. This is not the case with IDs. IDs are generally used for layout elements that will only be needed once. A great place to use IDs is for defining CSS rules for divs. Divs are considered layout elements because they contain content, such as graphics, text, and media that make up our web page. Each div normally requires its own unique set of attributes. One example is the position attribute. In most cases, when designing CSS layouts, you wouldn't have two divs in the same location on the web page. For this reason, we would need two IDs that define unique position attributes for each div. Let's create a style rule for our div before applying it to the div we created earlier. In order to create a style rule for our div and reference it as an ID, we need to declare it in the style sheet. Let's create our style tags and define the ID. We'll call this ID div1. And when defining an ID, you need to place the number sign in front of the name. This particular ID now contains 4 style definitions. The div will be 80% of the width of our content area. It will have a 3-pixel black border. The background of the div will be yellow, and any text contained in the div will be blue. And we'll also mention again that the style rule for our ID reference begins with a number sign, unlike our classes which began with a period. With our ID created, we can now reference this ID in our div tag. So we'll go ahead and apply the ID here. We need to reference the ID by name, and since we named it div1, we'll plug in div1. Now let's go ahead and save our file and preview it in our web browser to see the final result. So here we can see we have a 3-pixel black border. The background of the div is yellow. The text contained within the div is blue. And the div itself is 80% of the width of the full content area. In addition to referencing an ID in our div tag, we can also create a class and apply it to the div as well. Let's say we wanted all the text in our div to be underlined. Well, first, we need to create the class. So to remember that your class starts off with a period, followed by the class name, and this is the CSS syntax for underlined text. Next, we'll apply this class in our div tag. So just make a space, type class equals, and then in your quotations, put the name of the class, underline. Now we can save our file, preview it again, and we can now see that the class has been applied and all the text within our div is underlined. Now that we have an understanding of IDs, classes, and divs, we can explore some of the style definitions that allow us to customize the look of our HTML elements. We'll begin with margins. Margins allow you to add spacing around the perimeter of your element. A margin can be added to any one side or a combination of sides. Let's add some margins to the div we created in the last lecture. In order to see the bottom margin, we will need to place a line of text underneath the div. So enter a line of text, and you can enter this line of text in a new div underneath your original. Now to apply the margin, we need to add the margin definition to our div1 ID. This is because we're adding the margin to div1. To add a margin, simply type in margin, colon, and then the amount of the margin. We'll go with a 10 pixel margin to begin with, and we'll increase it to show you the difference. So let's take a look at what a 10 pixel margin looks like. So we've saved our file, and I'm just going to preview it in the web browser. This is the margin at 10 pixels. So a 10 pixel margin has been added to the top, the bottom, the left, and the right. Let's go ahead and increase the amount of the margin to see the difference. I'm going to go from a 10 pixel margin to a 30 pixel margin. And just save. And refresh the page. So you can see that it increases the amount of margin by 20 pixels. Now say for example, we didn't want to add a margin on every side. We only wanted to apply the margin to the bottom and left side. Well, in that case, our style definition would look like this. This instructs the web browser to put a 0 pixel margin on top. The second value is a 0 pixel margin on the right. The third represents the bottom margin, so that's 30 pixels on the bottom. And the last value is the left margin. So that's 30 pixels on the left side of the div. So I'll save that. And actually, I'll just increase it to 50 so we can actually see the difference. I'll save that and refresh the browser. Okay, so now we have no top margin, we have no right margin, but our left and bottom margin has increased. Padding creates spacing between the perimeter of an HTML element and the content contained within it. In this tutorial, we'll be adding padding around the text contained within our div. Similar to margins, padding can be added around all 4 sides of an element or only specified sides. First, we will add padding around all sides. To do that, type the following style definition in your div1 ID. This will add a 10 pixel gap between the text in our div to the perimeter of the div. So let's go ahead and save the file and take a look at it. So we can see that we have a 10 pixel gap around our text right up to the perimeter of the div. I'm going to increase this amount of the padding so we can better illustrate this example. So I've saved the file and I'm just going to refresh. And we can see this is now a 20 pixel padding around the text. Now let's add padding to only the top and left side of the text. To do this, enter the following values. We'll add 30 pixels on top, 0 on the right, 0 on the bottom, and 30 pixels on the left. So save the file, and I'll refresh. So now we have 30 pixels on the top, 30 pixels on the left, and 0 on the bottom and right. CSS allows many different text formatting options. We've worked with some of them in the past, but others will be new to you. We'll go through a number of them in this lecture. To begin, please open the exercise file located in the Downloads folder corresponding to this lesson. Once open, let's preview this file in our web browser. We can see that the file consists of a number of paragraphs of text. Each block of text is contained within an open and close div tag. We also have a style sheet that contains a number of classes relevant to text formatting. The classes are contained within the open and close style tags. We'll go through each definition contained within the classes to explain what they're used for. The first class contains a color style declaration. We've worked with this in the past. The color declaration will change the color of the text it is applied to. Let's go ahead and apply this class to the first paragraph. Now save the file and preview it in the browser. So we can see here that the first paragraph has changed to the color red. The next two classes are almost identical to the first. They are color declarations. The difference is these two declarations use color codes. The first declaration uses a web color code, and the second uses an RGB color code. If you're unsure what this means, please review our lecture on color codes. Let's go ahead and update our class reference to the second class. So text color 2. Now save the file and just refresh your browser, and we can see that the color is now green for the first paragraph. As you probably guessed, the third class will do the same thing. We'll just save that and refresh the browser. And we can see that the text color is now purple. The next class has a letter spacing declaration. This allows us to adjust the amount of space between each character in a word, sentence, or block of text. This declaration has a value of 10 pixels. You can increase this value for more spacing or decrease it for less. Let's apply this class to the second paragraph of text. I'll just copy it so that way it ensures I don't make any spelling mistakes when I'm entering it in. And then save the file. And I'll refresh the browser. So now we can see we have a 10 pixel space in between each character in this block of text. In addition to letter spacing, we also have the word spacing declaration. This allows us to adjust the spacing between words rather than letters. Let's apply this this class to the third paragraph. We'll save the file and reload our browser. So now we can see the 10 pixel spacing between each word in this paragraph. The next class we have is the text align declaration. This allows us to align our text using left, right, center, or justify as the value. The default is left, so let's go ahead and change this to center and see what happens. We'll also need to apply this class to any one of the paragraphs. Then we'll save it and refresh the browser. So we can see the alignment is now centered. Next, we have the text declaration. We've worked with this one before. The value of this declaration is currently underlined. Other possibilities include overline, line through, and blink. You can replace the underline with each one and apply the class to a paragraph to see the results. We also have the text transform declaration, which allows us to change text to capitalized letters. You can also change the value to lowercase by replacing capitalized with lowercase. So we'll go ahead and apply this class Now we'll just refresh our browser. There's only a couple of capital letters in this paragraph. So you can see that they've switched to lowercase now. And this time I'll change it to capitals and refresh. And we can see that the first letter of each word is now capitalized. If you want to change all the letters to uppercase characters, then you can use the uppercase declaration. And now all the characters are uppercase. In this lecture, we'll explore the font property to set various style declarations for text, such as font family, style, size, and line height. We'll be working on the same file we worked with in the last lecture. To begin, we need to create a class that will be used to change the font style of a paragraph of text in our body below. Let's call this style text style. We'll create each style declaration, then explain what the style declarations are used for. The first declaration is font family. This allows us to change the font face of the text. The reason we specify a font family is because your website visitor's browser may not support the first font specified, in this case, Verdana. If not, the browser will use the second font, and so on, if you have additional fonts specified. The next declaration is font size. As you guessed, this allows us to change the size of the font. There are many possible values, ranging from extra small to extra large. Font style allows us to make the text italic or oblique, or normal. Line height allows us to change the spacing between each line of text in a paragraph. The default line height in most browsers is about 110 to 120%, so any value above this amount will increase the spacing, and any value below it will decrease it. Let's save our file and preview it in our web browser to see what the paragraph looks like without the class applied. So we can see that this is the default style. And now we'll go ahead and add the class we just created. Save the file, and I'll just refresh the web browser. And as we can see here, this paragraph, the font style has changed to reflect the class that we added to the paragraph. In this lecture, we'll explore how to add borders around an element. We'll start by creating a class with commonly used border style declarations. We'll call this class myBorder. The first declaration, border, is used to specify where the border will be applied and at what thickness. The thickness is stated in pixels. At the moment, we have a 4-pixel thick border. For a border only at the top of an element, we would use the border top declaration. Border bottom, border right, and border left are also other values that can be used. If we leave it as just border, as we have now, the border will be applied to all 4 sides. Next, we have the border color. This will be the color of the border itself. The color value can be represented by a color name, such as red, green, or blue, a hexadecimal number, as we currently have, or an RGB value. We can also create a border style using the border style declaration. There are several possible styles. At the moment, we've used dashed, which will create a dashed line border effect. Let's go ahead and apply this class to one of our paragraphs. We'll apply it to the first paragraph. So make a space after your first class and paste the second, myBorder. Now we'll save our file and preview it in our browser. So here we can see we have the dashed border, which has been applied to the first paragraph. In this lecture, we'll work with adding backgrounds to elements using the background property. To begin, we'll need to create a file with our basic HTML structure as shown here. Once you've created this file, save it as backgrounds.html. We'll be applying a background to a div. So let's go ahead and create our div tags in the body. We'll also need to create an ID selector so we can reference the ID that will contain the background declarations for this div. Let's set that up in our style sheet. So we'll create a style sheet with the open and close style tags. Now let's insert our ID. We will call it div1. Now create the following declarations for this ID. Most of these declarations should look familiar. The background color declaration allows us to set a background color to an element. The value can be a color name, as we have here, the color blue. It can be a hexadecimal number or an RGB color code, all three of which we've worked with in the past. Let's apply this ID to our div and preview it in our web browser. So save the file and preview it. As you can see, our div has a blue background as defined in the background color declaration. In addition to a color background, we can also use an image as a background. To do this, we need to use the background image declaration. We'll use the image stored in the downloads folder corresponding to this lecture. The image is a JPEG file, and its dimensions are 204 pixels in width by 204 pixels in height. To add the background image, we'll need to replace the background color declaration with background image. Now we need to indicate the path for this background image. And the image is in the same folder as this HTML document, so all I have to do is plug in the name of the file. Now save your file again and preview it just to see the change. This is what your div should look like after adding the background image declaration. We can see that the background image was applied to our div and also repeated, so it fills the entire div with the specified image. Let's say we only wanted to repeat the background horizontally or along the x-axis. To do this, we can use the background repeat declaration. This declaration, repeat x, as the value, will repeat the background only along the x-axis, as you can see here. We can do the same vertically by changing the declaration to repeat y instead of repeat x. If we didn't want the background to repeat at all, we would use the no repeat declaration. And this is the actual image, and the background here is not repeating. Now say we wanted to specify the position of the background image placement. We can do that using the background position declaration. We'll set the position as center. And we can see that the background now no longer repeats and is also situated in the center of our div. There are also several other position values you can use as shown. At this point, you can go ahead and try different combinations of these declarations to see the effect each one will have on the end result. We can define the level of transparency or opaqueness of an image using the opacity declaration. Before we begin, set up your basic HTML structure and save the file as opacity.html. Once you've set up your basic HTML structure, create an open and close div tag within your body tags. Now we'll insert an image into this div. Once the image is inserted, we can adjust the opacity of the image. The image can be found in the Downloads folder corresponding to this lecture. Next, we need to set up our style sheet. Inside the style sheet, enter the following declaration. This is the opacity style declaration, and the 0.4 will set the opacity of any image in our document to 40%. Let's go ahead and take a look. Save the file and preview it in your web browser. And this is the image with the opacity set at 40%. Let's set it at 90% to see the difference it makes. And that's the opacity at 90%. We can add additional effects using the opacity declaration as well. Let's create a hover effect so that the image changes from 40% to 100% opacity when your mouse is hovered on top of the image. To do that, add the following declaration. Also change the original opacity declaration back to 40%. Now save your file and refresh your browser. And as you can see, when we hover our mouse over the image, it changes to 100% opacity. And when we remove the mouse, it changes back to 40% opacity. We can control the width and height of an element using the width and height declarations. For the purpose of this lesson, we'll apply various width and height attributes to a div to see the effect. To start, open the HTML file in your Downloads folder corresponding to this lesson. The file contains a div in the body and one ID selector, div1, which has been applied to the div. Let's preview this file in our web browser to see what it looks like. Here we can see the div is 100% width of the content area and 500 pixels in height, with a blue background. If we scale the browser window up and down, we can see that the div expands and contracts to suit the size of the content area. It is always 100% of the content area's width. CSS allows different values to be attributed to the width and height declaration. We'll begin with minimum width. Min width can be used to specify the minimum amount of width an element must be. Since the width is currently set to 100% of the content area, it will automatically stretch and contract with the browser window, as we saw previously. If we wanted to maintain a minimum fixed width of at least 600 pixels, we can apply the following declaration. Now, after you've saved your file, let's go ahead and refresh our browser. And this time you'll see that when the browser window becomes smaller than 600 pixels, we get the horizontal scroll bars. This is because this div, its minimum width must be 600 pixels. It will not go below that value. In addition to min width, we also have maximum width or max width. So if we set the maximum width to 800 pixels, now save the file and we refresh the browser, you'll notice that the div now does not go beyond 800 pixels. So we have a minimum width set at 600 and a maximum of 800. Width can also be set to auto. So let's go ahead and set the width declaration value to auto. And this will make the width of the element automatically size to its container. In this case, the div is not nested in another div, so it will expand to the full size of the browser's content area. Now we do have to remove the max width declaration in order for the auto declaration to work. So once you've saved, refresh your browser, and you'll notice that it now scales to the full width of the content area automatically. Similar to min width and max width, we also have min height and max height. These values can be stated in pixels or percentage, just like they can with min width and max width. An important difference between the width and height declarations is that setting the height to 100% will not result in your div occupying 100% of your browser's content area. So for example, if we were to change the height here to 100% and refresh our content area, refresh our browser, you'll notice that the div disappears altogether. In order to do this, we need to use the VH unit that's available with recent versions of CSS. VH, which stands for viewport height, ensures that the element stretches to the full height 100% of any device's viewport. So let's go ahead and change the height value to 100 VH. Save the file. And when we refresh, you can see that it is now 100% of the height and 100% of the width. In this lecture, we'll be placing text on an image using CSS as shown in this example. Here, you can see we have a div that contains a background image. We also have a div that contains a semi-transparent text box with some text. In order to do this, we'll be working with nested divs. A nested div is a div that is contained within another. The div that contains the nested div is known as a container. To begin, create a basic HTML page structure and save the file as imagetext.html. The files for this lesson are located in your Downloads folder. Now let's create a style sheet with two ID selectors. One ID for the div that will have the background image, and the second for the div that will contain the black text box. We'll call the first ID selector background. We'll start with the background image declaration. We'll set the path to the txtbg.jpg file. And again, this file is located in your downloads folder. Once you have that declaration complete, also put in a padding declaration of 40 pixels. The padding declaration will add a 40 pixel space between the text box perimeter and the background perimeter, as shown here. That's this space right over here. Now we'll create the second ID selector. And we'll call this text box. We can set the width to auto. So it takes up the full length of its container, which will be the background div. Set the height to 100 pixels. Opacity will set to 80%. Background color is black. And the padding will be 10 pixels. This will create some spacing from the text inside the div to the perimeter of the black text box. You can see we have a space here. Lastly, we need to create one class, and this will just make our text color white. With our style sheet complete, we can create our divs in the body, between the body tags. The first div will be our background. So we'll reference the background ID. Inside the background, we'll be nesting the text box div. And inside the text box div, we'll be nesting a div that will contain the text. So we'll attach the text class to this div. Okay, now you'll just need to type some text inside this div. You can either copy a block of text or you can type your own. I'll just paste in a block I have here. So with that created, we can save our file. And let's go ahead and preview it. And so there we have it. The background image, the text box, and the white text contained within the text box. You can also see that the background of the text box is semi-transparent. We can use the display property to change the visibility or positioning of an element relative to another. On this HTML page, we've set up 4 style definitions, one for each div that we have in our HTML body: container, div1, div2, and div3, and we can see the corresponding IDs here. The first definition is for the container div. It specifies that the div will have a width and height of 400 pixels and a 1 pixel black border. Inside the container, we have 3 additional divs, div 1, 2, and 3. Each one of these nested divs has a width and height property set to 50 pixels and also a background color. And each of the divs have a different background color so we can distinguish between them. If we take a look at this file in our web browser, we can see that by default, each nested div falls one below the other. But what if we wanted each div to be displayed next to the other in a line? To do that, we can add the display property to each div. We'll set the value of this property to inline block. Now if we refresh the page, you can see that each div is now beside the other. We can also set the display property to none if we want to make an element invisible. So for example, if we did not want div3 to be visible, just change display to none. And I'll save the file and refresh, and you can see that we can no longer see that element. We can position our HTML elements in different ways, using the position property in our style sheet. Positioning is a very important concept because it will be used extensively when developing CSS-based web page layouts. There are 4 main types of position declarations that we will explore: static, relative, absolute, and fixed. The first and most basic position declaration is the static position. Static is actually the default position of an element if no position is specified. We've already worked with this many times. On this HTML page, we have a div that references ID selector div1. We've defined some basic properties, including background color, width, and height. Note that we have not declared a position property. Let's take a look at this page in our web browser to see what it looks like. We can see that the div is positioned where we might expect, at the top left corner of the content area, because that's where the content of our body would normally begin. Without specifying a position property, the default position is known as the static position. The element will inherit its position based on the normal flow of content on the page. If we wanted to specify the position is static, we could do so by creating this declaration. And when we refresh our web browser, there should be no change in positioning. Relative positioning allows us to add additional properties to a position declaration that specify the top, left, right, and bottom position coordinates of the element. To illustrate an example, let's add the following properties to our style rule. Now, if we were to refresh our web page and take a look at this in our web browser, we'll notice that nothing has changed. Even though we've specified the top and left position, the element is in the exact same place it was prior to adding those declarations. The reason for this is because our position is still set to static. Let's go ahead and change the position to relative and see the difference. We can now see that this element has moved from 50 pixels from the left side of our content area and 50 pixels down from the top of our content area. Now let's work with nested divs. We're going to create a div inside this div and see how the relative positioning is affected when we're working with nested and parent divs. The first thing we need to do is create the ID selector for the nested div. We'll call it div2. And we'll create some properties for this div. We're making it a different color, and we'll also make it a different size, so then that way we can clearly see a distinction between our original div and this new nested div. Okay, we'll keep the position as relative to see how a relative positioned div behaves inside of another div that it also has the same position declaration. So we'll go ahead and insert our nested div in our body. We'll reference ID selector div2. And we'll just save our file. And this is what the new document looks like. We can see that our nested div is situated within our parent, our container div. Now we want to move the nested div 80 pixels from the top and left relative to the parent div. In order to do this, all we need to do is add the top and left declarations to our style rule. Now when we save our file and refresh, we can see that the nested div has moved 80 pixels from the top and 80 pixels from the left relative not to the web browser's content area, but to its parent div. So keep that in mind. Another position property is absolute positioning. Absolute positioning will ensure the element stays in the exact same position specified in the style rule. It does not consider the flow of the page when you resize the browser window. Let's take a look at an example to illustrate this concept. Say we added a block of text above our div tags. I'm just copying a block of text and I'm going to add it above the div tags here. Now I'm going to save the file and we're going to preview this page in the web browser. Take a look at what happens when we scale the browser, when we resize it to bigger and smaller. You'll see that the div is moving up and down to accommodate the text as the browser shrinks and expands. With relative positioning, the div moves with the flow of the page. Now let's change the position of our parent div to absolute. Okay, remember that div1 is our parent, and we'll change the position to absolute. Now when we save the page and refresh it, you'll see that the div remains in the exact same position as specified in our style declaration. This is regardless of what we do. So if we were to resize the browser now, the parent div will stay in the exact same position we specified. Notice that the nested div, div2, is still relative to its parent div. The last element position property we'll discuss is the fixed position. Fixed position is similar to absolute positioning. The difference is that with fixed positioning, the element does not scroll with the page. Let's take a look at an example. To see the difference between absolute and fixed positioning, we need to insert a much larger block of text above our div tags. This will force the page to allow scrolling. So I'm going to copy a large block of text and I'm going to paste it. So you can see that it's a lot longer than the previous block of text. So if I save the page and I preview it in the web browser, we can see that the page now scrolls. Okay, so we went over absolute positioning. Okay, our parent in the last exercise had absolute positioning, and we can see that with absolute positioning, the parent div does in fact move with the rest of the content when you scroll up and down. Now let's change the position to fixed. And when we save the file, refresh our browser, you can see now that the parent div does not move up and down as you scroll through the contents of the web page. And that is the difference there between fixed and absolute positioning. The float property is used to wrap images around HTML elements, such as images, as shown in this example. In this tutorial, we'll create this effect. First, we need to set up our basic HTML page structure. Once complete, save the file as float.html. Now we need to enter a block of text in our body. Make sure that the block of text is long enough so that there is enough text to wrap around the image you're inserting. I've copied a large block of text and I'm pasting it within the body tags. Next, we'll insert the image that will be used for this tutorial. You can use your own image, or you can use the one provided in the Downloads folder corresponding to this lesson. Now we need to create the float effect by creating a style sheet and inserting the following style declaration. Now to create the float effect, float right means the image will appear on the right of the text. We could also use the float left declaration if that was our intention. In that case, the image would appear on the left side of the text. We've also added a margin so there is space on the left and bottom side of the image. Let's save our file and preview it in our web browser. And as you can see, the text is now wrapped around the image with a text 10 pixel margin on the left side and on the bottom of the image as well. The clear property is used to control the behavior of floating elements. Elements that are positioned after a floating element will flow around it. This HTML page shows an example of this. The page contains 3 divs. One is blue, the other is red, and one is yellow. The blue div has a float left property attached to it. For this reason, the text contained in the red div floats to the right side of the blue div. We can see the text wrap around the blue div. In order to prevent the yellow div from floating to the right as well, we've put a clear declaration. This forces the div below the blue div, unlike the red div, which does not have a clear declaration. The z-index property allows us to specify the stack order of an element. To better illustrate this, let's take a look at an example. On this HTML page, we've defined the style for 2 divs, div blue and div yellow. The blue div has a width of 600 pixels, a height of 50 pixels, background color of blue. Its position from the top is 0 pixels, and a position property set to absolute. The yellow div is almost identical, except the width is 400 pixels, height is 400 pixels, and the background color is yellow. Since they both have the exact same top position, these 2 divs are stacked on top of one another. So let's take a look at this in our web browser to see what it looks like. We can see that by default, the yellow div is on top of the blue div. But what if we wanted the yellow div underneath the blue div? In this case, we need to specify the z-index property for each div. Let's give the yellow div a z-index of 1, and the blue div a z-index of 2. I've saved the page and I'm going to refresh, and we can now see that the blue div is on top of the yellow div because it has a higher z-index. In this lesson, we'll be styling links using CSS. A link can have 4 different states: unvisited, visited, hover, and active. An unvisited link means the user has not yet clicked on the link. A visited link means the user has clicked on the link. The hover state is when the user's mouse is hovering over the link. The active state is the exact moment that the link is clicked. Knowing this is important because we need to define a style rule for each state. On our HTML page here on the left, we can see an example of how this is done. To identify a link, we start with the A property followed by a colon. Next, we specify the state. We've started with just the default state, link. We've set the color to red with no text decoration, and we can see that in our web browser. The color is red and there's no underline or any other form of text decoration. The hover link has a color rule set to purple, as well as a text decoration set to underline and background color set to yellow. So let's see the effect that produces. You can see the background is yellow. The text changes from red to purple and it is now underlined. When the link is clicked, we can see that the selected link property activates. So when we click it, the purple or the red changes to blue. Lastly, we have a visited link property with color set to blue. That means if somebody were to visit the link that this link points to, then the red would automatically default to blue because it would now be considered a visited link. We can greatly improve the look, styling, and responsiveness of an HTML table by using CSS tables. Here, we have an example of a CSS table with some basic formatting. On the left, let's take a look at the way the code is structured for this table. I'm going to scroll down to the body tags and we'll take a look at the style sheet in a moment. Inside our body tag, we have our open and close table tags. Inside the table tags, we also have the TR tags that represent the table rows, the TH tags for the table headings, and the TD tags for the table columns. We're already familiar with table row and table columns, but table headings may be new to you. The TH tag represents the table heading, and it makes styling the headings of your table much more convenient. Let's take a look at our style sheet now. Here we have 4 style definitions. The first will apply a 1 pixel border to the table column, and the table headings. The text alignment is also set to left. So a border and text alignment. Next, we've set a border collapse property to the table style rule. This collapses the table borders into a single border. It just makes it look a lot neater. I'll take this out just to show you what it looks like without it. So you can see that we now have the double border look going on. I'll add that back in. The next rule adds 15 pixel padding around our table headers and table columns. So you can see there's a fair bit of spacing around the text inside each cell. Lastly, we've added a hover effect to our table rows using the TR hover rule. As we hover our mouse over the rows, the background changes to cyan. And so as you can see, there's a lot more you can do with CSS tables versus regular HTML tables. Now that we're familiar with CSS, we'll work on creating a CSS-based web page using a commonly used 3-column responsive layout. This is what the final result will look like. We'll have a navigation menu at the top with 4 links. Each link has a mouse over effect, and one of the links is active by default. The navigation bar is also nested inside a header div, and that's the black background area that you see behind the navigation. Next, we have our 3 columns, which will hold the content of our page. We've placed text content in this example to keep it simple and easy to follow. The 3 columns are designed to collapse below one another depending on the user's screen size. As you can see, when we shrink the screen, the header is on top. The center content area is second, followed by the blue and yellow content areas. At the very bottom, we have our footer as well. This makes the web page fully compatible with any mobile device and any screen size. So with that out of the way, we'll go ahead and get started. The first step in this project is to create our basic HTML page structure as shown here. Once you've done that, save the file on your computer. You can name the file whatever you like. Next, we'll create a style sheet for our CSS rules. So inside your head tag, create your open and close style tags. We'll start with creating our first rule. This will be for the body property. Create a margin definition set to 0, padding set to 0, and a line height set to 1.5 em. This will ensure there is no spacing around the perimeter of our page content. It also sets the default line spacing for the text on our page. Next, we'll create a set of definitions for our header. So this is for the header div. Start with a background definition set to black. We'll set the font family to Arial and a height of 100 pixels. And so that is for this piece over here, the black background underneath the navigation. Now we'll need to create a style rule for the div that will contain our 3 columns. So column 1, 2, and 3. We'll name this rule content wrapper. Since we need the footer to attach itself beneath the content wrapper, we need to set a float left property on the wrapper. So that's what we've done here. We've also given the wrapper a width of 100%. This is because we're creating a fluid layout which scales and shrinks to the full width of the browser's content area. So as I expand the browser, you'll notice that the layout expands with it and contracts with it, so it's fluid. Inside the content wrapper, we need to create a style rule that will contain each individual column. For this rule, we'll create one definition, and that definition will be margin. Set the margin to 0, 230 px, 0, and 230 pixels again, and call it content column. This means that the left column and the right column will be a fixed 230 pixels at all times. The center content area will be fluid. So as I expand the browser, you'll notice that the middle content area expands and contracts, where the left and right column stay at a fixed 230 pixels. Now we can set the rules for our left and right columns. We'll start with the left. So create the following style rule. We'll call it left column. That's what we'll name our div. For this, create a float definition and set it to left. Also set the width to 230 pixels. Set a margin left definition to -100%. This will help ensure that the columns remain positioned correctly. And for the background color, set it to this value, or you can set it to another background color if you like as well. Now for the right column, again, set the float to left, width to 230 pixels. This time set the margin left definition to -230 pixels. Again, this is for the purpose of making sure that the columns stay in the right position, regardless of the browser's size. And we've set the background color to this value, which is this yellowish background, but you can use whatever color you like. Next, we need to create a rule for the div that will hold our text content. So we'll call it inner text, and it's a class, and it'll be applied to any div that contains text content. So for example, here, here, and here. You can see that around the text we have a margin, and that's a 20 pixel margin. The font family is Arial, and the color of the text is a light gray color, and this is the hex code for the color. Now we'll create a rule for the footer, and that's this black bar right at the bottom. First, we'll create the clear rule and set it to left. And this will ensure that the footer stays in the correct position at the bottom of the content wrapper. Set the width to 100%. Background is black. The text color is white. Font is Arial. Text alignment inside the div is center. And there's a bit of a padding, 4 pixel padding around the text. With our main styles created, we can now go ahead and create the styles for our navigation menu. The navigation links will be contained within an unordered list, and for this reason, we'll start by creating a rule for our UL elements. I'll just create a comment to separate our main styles from the navigation bar, and this is our first style here. So for the UL elements, we've set the list style type to none, and this will make sure that there's no bullets or numbering next to each item in the list. The margin padding is set to 0, and the background color is set to black. Next, we'll create a list rule and give it a float definition of left. This will make sure that all the links appear in one row next to one another. Also set a border right definition and set the values to 1 pixel solid and this hex code for the color. We'll need to create a rule for the last element in the list, which is the contact link. And what we want to do is we don't want a border at the end of this one. So set the last child attribute of the list property, give it a border right none definition. Now we'll create a definition for the link elements in the list. So for any A attribute contained within a list element, we've set the display to block, color to white, text alignment to center. We've added a bit of padding around the text and no text decoration. We'll need to create a rule for the mouse over effect that you see here. And so this is how it's done. Just create a background color definition and set it to this hex code. And that's what's going to give this effect here. Lastly, we'll create a rule to set the background color of the first link to blue. So this will be an active link. Just indicates to the user what page they're on. And so it's an active class with a background color set to this hex code. Now we'll create the style rules to make our layout responsive on mobile devices. We'll start with devices that have a maximum screen size of 840 pixels. For these, we'll drop the right column under the other two columns. Let's take a look at an example. So when the screen size falls below 840 pixels, you'll notice that the right column falls underneath the other two. So that's the first rule we want to set up. So I'll start with a comment just to separate it from the navigation styles. We'll need to start with a media property and set the max width to 840 pixels. Now we'll create a rule for the left column and set the margin left definition to -100%. Now we'll create a rule for the right column, set float to none, width to 100%, margin left to 0, and clear to both. Create a rule for the content column, just set the margin right to 0. And then just close our open media style. Now we'll create a set of rules for devices with a max screen size of 600 pixels. So at below 600 pixels, we want both the left and the right column to be positioned underneath the main center content area. So that makes it fully responsive on all devices. So we have two rules, one for the left column and one for the content column. So you can go ahead and enter those. And once you've finished that, we've completed our entire style sheet. And in the next lesson, we'll start building the page in our body tags. Now that we have our style rules created, we can go ahead and create our divs inside the body tags. First, we will create a container that will contain all the elements of our page. Inside the container, we'll insert the header. And remember that the header contains our navigation. And the navigation elements are structured within an unordered list. So that's what that will look like. Next, we'll insert our content wrapper. And the content wrapper again will contain all our three columns. And then insert the content column div. This is the center content area, and we created the inner text rule that adds the padding or the margin around our text. So we'll go ahead and insert the inner text div. And inside this div, we'll insert some text. The next div we want to insert is the left column. And so just create this code block. So we have the div for the left column, and then inside the left column, again, we're using the inner text div to add margin and some font styling to our text. And this is just some random text that we've entered. And we'll do the same for the right column. And the last thing we'll enter is our footer. And that's the entire page completed. So go ahead and preview it in your browser. And this is the end result. So that's a responsive CSS layout. An important concept to understand before moving into JavaScript and jQuery is the document object model, or the DOM. The DOM is best defined as a tree of objects created by your web browser when the web page loads. Your web browser uses the DOM to interpret the page and display its contents. Let's take a look at the model illustrated as a flowchart. At the top of the model hierarchy, we have our actual HTML document. For example, index.html or main.html, whatever the case may be. Inside our HTML document, we have our root element, which is the HTML open tag. Inside the root element, we have several other elements, for example, the head tag and title tag. The root element also holds the body element, which can contain links, paragraphs, headings, divs, and just about any other element we can use to develop the content of our page. Each of these elements can have text content and attributes. For example, the A element contains an href attribute, which contains a textual link. The DOM is important to understand because it allows the elements on a web page to be dynamically changed or updated using JavaScript or the jQuery library. This means we can change HTML elements, attributes, and CSS styles when different events are triggered. For example, if a button is clicked or a page is loaded, just to name a few. We can specify which elements to update or change on an event using three methods. First, we can use the tag name. Say, for example, we wanted to change all the text contained within h1 tags to red. In this case, we would specify the h1 tags in our JavaScript. If we wanted to change a specific element, we can refer to it using an ID. For example, we can assign the ID equals text to a paragraph element. So PID equals text. We can then modify the element or any of its attributes using JavaScript. Thirdly, and similar to the ID method, we can also refer to an element by assigning it a class. For example, if we wanted to modify a list element, a specific list element, we could attach the class bullet1, for example. And we could change it using JavaScript as well. In the next lesson, we'll take a look at a few examples of how we can change elements inside the document object model. In this lesson, we'll take a look at a basic example of DOM manipulation using JavaScript. In the JavaScript portion of this course, we'll cover many more methods. Here we have a basic HTML document. Inside the body tag, we have a JavaScript function named changeText. This function will change any text contained within an element to the words new text. Outside of our script, we have an h1 tag with an onClick event attached to it. The onClick event will execute the changeText function. This means that the text inside the h1 element, click here, will change to the words new text, as defined in our function. Let's take a look at this in our web browser to confirm it works. You can see that when I click on the words click here, it changes to new text. And so we've manipulated the document object model. So far, we've worked with HTML and CSS. We know that both these programming languages instruct our web browser on how our web page should be displayed. We also learned that HTML and CSS are static languages that do not interact with users. In this section of the course, we'll be exploring a very powerful client-side programming language known as JavaScript. When we say client-side, it means the language communicates with our web browser to allow user-to-web page interactivity. Client-side languages differ from server-side languages such as PHP, which we'll cover later on. Server-side languages communicate not with a web browser, but with a web server. JavaScript can be used to implement many different types of interactive features on a web page. Let's take a look at some examples of JavaScript functions that interact with users. This JavaScript code calculates the amount of characters a user has typed into a text area. Once you type in the line of text and press the Calculate Characters button, you'll see that this line of text has 23 characters. This JavaScript code displays an error message if more than 10 words were typed into a text area. This is the pop-up alert that appears if more than 10 words are typed in. This JavaScript code validates a form to make sure that the required fields were completed. I've purposely put an incorrect email address and left the other fields blank. These fields are required. So once we click Submit, we receive an error message saying that some of the required fields were not completed. This is done using JavaScript validation. We'll explore much more advanced validation techniques than this. This is just a basic example. This JavaScript code ensures a user agrees to the terms and conditions of a web page in order to submit a form. If I do not check off this checkbox here, you'll notice I get a pop-up message saying that we must check the box to continue. And again, this is another JavaScript function. This is a slightly more advanced script. It's a tic-tac-toe game. And the purpose is to line up the X's or O's all in one straight line, diagonally, horizontally, or vertically. And so you can see if you lose, a pop-up message appears indicating that the game is over and you've lost. These are just a few basic examples of what JavaScript can be used for. JavaScript does have some limitations. We've already touched on one in that it cannot be used to communicate with a web server. JavaScript cannot be forced onto a user's web browser either. Remember, JavaScript is a client-side language, meaning if your user has turned off JavaScript support in their web browser, your script will not work. Also, if the user's web browser is outdated, it may not allow certain JavaScript functions to work correctly. Note that almost all modern web browsers support JavaScript by default when installed. Many people also confuse JavaScript with Java. Note that these are two languages and they are not the same. Java is a much more powerful and complex language in the same category as C and C++. JavaScript is an object-oriented language. This means that attributes of an object are contained within variables. For example, if we want to describe a person, we'll refer to this person as the object. We would typically use attributes such as name, height, weight, gender, and age. The values of these attributes will vary or differ from person to person. Another word for attributes is variables. These variables will contain the values for each person. As we progress through this section, you'll gain a better understanding of this concept and the importance of working with variables. Similar to CSS, JavaScript functions are most commonly placed in between the open and close head tags. The reason for this is because the head portion of an HTML page gets loaded before any other part of the HTML document. So if you were to put your JavaScript code right before the closing body tag, any JavaScript calls made to functions by your page as it loads will result in an error. Let's take a look at an example of a JavaScript function located in our head tag and called upon in our body. We won't get too much into the HTML here because by now most of this HTML code should look familiar. This JavaScript code will calculate your age in dog years. A year of a person's life is equivalent to 7 years of a dog's life. Let's preview this file before we take a look at the code. As you can see, we input our age in the first input field. I'll put 1 just for demonstration. Once we press calculate, the JavaScript function is called. It reads the value in the first input and multiplies it by 7. It places the result in the second input. In the code, we can see that the script for the JavaScript function is located in the head tag. The function itself is called cYears. This function takes the value of the form element my age and multiplies it by 7. The result is then displayed in the form element dog age. The entire function is activated when the user clicks the calculate button. This is when the JavaScript function is called. We can see an on-click event attached to the button. We'll explore different events later in this course. JavaScript can be inserted into a separate document and called when necessary. This is known as an external JavaScript file. You might recall we did the same with our external CSS file. Let's take the JavaScript function in our previous lesson and insert it into a new file. I'm going to copy out the entire function, I'm going to cut it. I'm going to create a new file and paste it. Now I'm going to save this file as dogage.js. JS stands for JavaScript. Now in the head tag, we need to call this script. And we'll do that by adding a source attribute to the script tag. Now we'll save this file, and I'll preview it in my browser just to make sure it works. We can see that the script is working, so we know that the JavaScript file was called successfully. There's a couple of advantages to using external JavaScript files. First, it makes the HTML code and JavaScript code easier to maintain. Cached JavaScript files also increase the speed at which the web page loads. There are different methods we can use for outputting data using JavaScript. The first we'll explore is the document.write method. Let's take a look at an example to see how this works. In this HTML page, we have a script that will display the result of a simple calculation using document.write. You can see here we have two values and we want to add them together, 5 plus 6. The result of this equation will be displayed in the content area of our web browser because we have attached the document.write function next to it. So here's the web browser, and we can see that the results are displayed beneath this line of text. So if we were to change the equation and save our file, it would update the value. And so it's that simple. That's how the document.write function works. Another method of outputting data is the window alert. This method will output the data in a pop-up message box. So let's replace the document.write with window.alert and see the difference. So now we can see that we get a pop-up message box with the value 13. The inner HTML function allows us to output data in an HTML element. For example, here we have a script that will calculate the results of a simple calculation, 6 plus 3. The script will display the result in the HTML element containing the ID math. That's what the getElementById function means. We've applied the ID to this paragraph tag. That means the results of the JavaScript output will be displayed here. We can see the results in our web browser. 9 is the result that is outputted once the JavaScript function computes 6 plus 3. We can update these values to output different results. When working with long, complex blocks of code, it's a good practice to leave comments that explain the function of the code. This helps you remember the purpose of the code and is especially useful if a third party will be working on the same script, such as another programmer or a team of programmers. JavaScript allows for single-line or multi-line comments. In this HTML file, we have a sample of both. The first is a single-line comment represented by the double slash. It's placed above an executable JavaScript function. This means the JavaScript function will still be executed. We can see the result in our web browser. The word test is outputted using the inner HTML function. In our next example, we've prevented a line of JavaScript code from executing by converting it into a comment. You can see that we've placed the double slash in front of the JavaScript code. So for this reason, the word paragraph is not outputted in our browser, despite using the inner HTML function. If we remove the comment, the code does execute. Lastly, we have an example of a multi-line comment, and these are best used for explanations of large code blocks. To create one, use the slash and asterisk combination. JavaScript constants are values that are fixed. For example, in this script, we're adding two values, 5 and 6, together and outputting the result in a paragraph with the ID math. The values that we're adding are fixed values, 5 and 6. The value of these numbers is not dependent on any other factor. The 5 will always be 5, and the 6 will always be 6, unless we change them in the script. Let's preview this file to see the result in our web browser. Here we can see the outputted result 11. Constants can be in the form of numbers, both whole and integer, or strings. Strings are written within double or single quotes. We'll go ahead and change one of these values to a string. Now when we save the file and reload our web browser, we can now see that my text is joined with the value 6. We touched on variables in the introduction of this course. Variables are a very important concept to understand when it comes to programming in any language, including JavaScript. Unlike JavaScript constants, variables are named containers that can store a single value or multiple values. These values can change based on user inputs or other factors. Let's take a look at a basic example of how variables can be used to store values. In this JavaScript code, we've declared three variables: variable x, y, and z. You can think of each variable as a container. The variables each contain their own value. The value of variable x is 10. The value of variable y is 15. The value of variable z is equal to the sum of variable x and y, which in this case would be 25, or 10 plus 15. Now let's output the value of c using the getElementById output method. We'll output the result in a paragraph with the ID demo. Now let's save our file and preview it in our web browser to see the results. Here we can see our heading, JavaScript variables, and our paragraph, working with variables. And underneath that, we can see the result has been outputted. So variable x has been added to variable y, and the result has been outputted to 25. In our example, the x, y, and z name we attach to the variable are known as variable identifiers. Each variable you declare must have a unique identifier. We used very short identifiers, but as we progress through the course, we will be using more descriptive identifiers. For example, color, shape, size, age, and weight. These would all be considered more descriptive. There are some general rules when selecting identifier names. Names can contain letters, digits, underscores, and dollar signs. Names must begin with a letter. Names are case sensitive. Reserved words, like JavaScript keywords, cannot be used as names. JavaScript variables can hold numbers like 100 or 10.5 or text values, for example, John Smith. Text values are known as text strings. Strings must be written in single or double quotes. Numbers can be written without quotes. If you put quotes around a number, it will be treated as a string. For the sake of this example, let's change our numerical value 15 to a text value. Now when we save our file and refresh our browser, we can see that the numerical value 10 stored within the x variable has been attached to the string contained within variable y. The output is contained within variable z, which equals x plus y. In JavaScript, the equal sign is an assignment operator. This sounds more confusing than it is. It just means that the value of the left operand is equal to the right operand. In the equation, x equals y, the equal sign assigns the value of y to x. This is important because it allows us to compute values of two different data types, such as numbers and strings. Let's take a look at an example. In this JavaScript code, we're adding a numerical value with a text string. If we save the file and preview it in our web browser, we can see that the numerical value 30 is attached to the text string hats. Arithmetic operators are used to perform arithmetic on numbers, both constants and variables. This chart provides a quick overview of the different operators that can be used. Now let's go over some examples to see how each one works. We'll begin by adding two numerical values. In between our open and close script tags, we'll create a variable called x. The value of x will be 100 plus 50. Next, we'll create our getElementById, and the ID will be the word add. Now we'll go ahead and create the paragraph that'll contain the outputted value. Okay, now let's go ahead and save our file and preview it in our web browser. And we can see that we get the value 150, which is the correct value. Now let's go ahead and perform another calculation. This time we'll add two values and multiply the result by the value of another variable. So let's go ahead and define two variables. Variable A, which will equal 3. Variable B, which will equal 20 plus 30 multiplied by A. So in this case, it'll be multiplied by 3. Now we'll just create our output. We'll call the ID add2. And we'll display the result underneath our first calculation. And we'll save the file and refresh our web browser. So here we have, once again, 150 outputted. Okay, so that would be 20 plus 30, which is 50, multiplied by 3, which equates to 150. Okay, in this next example, we'll subtract two values. We'll call the variable C, and we'll do 100 minus 50, and this time we'll give it the ID sub, and we'll output the result at the bottom of our other two calculations. And there we have it. So that's how we multiply, add, and subtract. In this lesson, we'll explore a few other arithmetic operators. We'll begin with division. In this example, we'll divide two values together. We'll start by declaring a variable. We'll call it D. The value of D will be 100 divided by 50. Next, we'll set up our output. We'll call the ID div I. And we'll set up a paragraph in our body tag to display the output. And once we save our file, we'll go ahead and preview it in our web browser. And we can see that the correct value is outputted. Next, we'll increment the value of variable. So to do that, for this example, we'll go ahead and declare a variable called x and give it the value of 5. Next, type in x plus plus and a semicolon. This will increment the value of x by 1. So if x equals 5, the next value up would be 6. We'll store the incremented value in a variable called z. And then we'll go ahead and set up our output. Now we'll go ahead and save the file and refresh our web browser, and we can see the value 6 outputted below our last calculation. We can also decrement the value of a variable. So instead of going up, this time we'll set up a calculation, an arithmetic that decreases the value of the variable. So instead of going from 5 to 6, we'll go from 5 to 4. We'll set up a new variable, and we'll call this variable h. Next, type in h minus minus and the semicolon. We'll store the new value in a variable called k and set up our output. Now we'll save our file and refresh our web browser, and we can see that the value of k is outputted. Operator precedence determines the order in which operations are performed in an arithmetic expression. As in traditional school mathematics, the order of computations follows the following sequence: brackets, exponents, division, multiplication, addition, and subtraction. To illustrate this example, let's take a look at a basic equation. Here, we have 50 plus 200 in brackets multiplied by 3. In this equation, 50 would be added to 200 first. The result would then be multiplied by 3. We'll go ahead and test this in our web browser, and we can see we get the correct result, 750. JavaScript variables can hold many data types, including numbers, strings, arrays, and objects. On this slide, we can see that the first variable, age, contains a single numerical value, 16. The second variable, last name, stores a string, Johnson. The variable cars stores multiple strings. This is known as an array. We'll explore arrays in more detail later in this course. The last variable, person, is an object. Object variables also store multiple values, but each value is relevant to an assigned property. For this reason, each name and value in an object is referred to as a single property. In this case, first name John is our first property of the object person. Don't worry if you find this confusing. We'll work with objects later in this course. In this lesson, we're going to explore JavaScript objects. To best illustrate how objects work, let's think of a real-life object, a car for example. A car has various properties like name, model, weight, and color. We can include the values for each of these properties inside a single JavaScript object. In this example, we've defined a variable named car. The car variable is an object and contains several properties, including type, model, and color. If we wanted to output the value of a single property inside this object, we can use our getElementById output method. We can type car.type to output the car type. Let's go ahead and test this file in our web browser and see what the output results in. Here we can see that the output is Acura, which correctly reflects the type of the car. Now, if we wanted to output the model, we simply need to update from car type to car model. We can save our file and refresh the page. And now we have the model outputted in our web browser. We can output multiple object property values in a single line of text as shown in this script. Here we have a variable object named person. This object has 4 different properties: first name, last name, age, and eye color. Using our getElementById output method, we can call multiple property values to form a sentence. Each value, in addition to the first one, can be added with a plus sign. The text strings in between the variable properties must be in quotes. This particular script will list the first property value, which is the first name. So for example, John has, and then the eye color property, so in this case blue. John has blue eyes. that will be the output in our web browser. And we can test that by launching this script in our web browser. And as you can see here, it outputs the correct sentence. We've worked a bit with JavaScript strings already. A string simply stores a series of characters. For example, John Smith. A string can be any text inside quotes. You can use both single and double quotes. Let's take a look at an example. In this script, we have two variables, student name 1 and student name 2. Each variable contains the full name of an individual. The first variable contains John Smith, and the second contains Roy Martin. As you can see, the first name is separated from the last name by a single space. The first variable is nested inside double quotes. The second is nested in single quotes. Both methods will work. We've outputted each string on an individual line, and we've separated each variable using the break tag. You might recall the break tag from the HTML section of this course. Let's take a look at what this script looks like in our web browser. Here we can see each variable outputted on its own line in our web browser. Now let's take a look at another example to illustrate the use of quotes inside of a string. We now have three variables, line 1, line 2, and line 3. In line 1, we use an apostrophe in the first word. This is acceptable in JavaScript. Variable line 2 and line 3 show the correct method of using quotes inside a string. You can use quotes as long as they don't match the quotes surrounding the string. So for variable line 2, we've used double quotes surrounding the string, and for that reason, single quotes around the name Xavier. On line 3, we've used single quotes surrounding the string, and for that reason, we've had to use double quotes around the name Xavier. We'll save our file and preview it in our web browser, and we can see that everything works correctly. We can see the apostrophe in the first line. We can see our single quotes and our double quotes outputted from variable 2 and 3. We can determine the length of a string using the built-in property length. In this example script, we have a variable called txt, which contains all 26 letters of the alphabet. To output the length of this string, we can set our inner HTML property to txt.length. With your file saved, preview it in your web browser, and you can see that it outputs the length of the variable, 26. As we're aware, strings must be written within quotes. Let's see what happens when we create a variable and put quotes inside of the string. In this example, we've placed quotes around the word players in our sentence. If we go ahead and preview this file in our web browser, we can see here that the text does not output as it should. To eliminate this issue, we need to use the \escape character. We must put 1 before the initial quote, and went over here. Now when we save the file and refresh our web browser, we can see that the sentence correctly displays with quotations around the word players. And that is how you deal with special characters that you have issues with in JavaScript output. We can use JavaScript functions to generate a random number. This can be done using the math.random function. This function will generate a number between 0 and 1. Let's take a look at how it works using this example script. Here, we're using the getElementById output method to output a random number. And there's the math.random function. Let's go ahead and save the file and preview it in our web browser. Here, we can see a random number is generated. If we refresh the page, it'll generate different random numbers. The value is always between 0 and 1. We can use the math.min or math.max function to find the lowest or highest value in a list of arguments. This example script provides an illustration of how this works. Here, we have a list of numerical values. We can use the math.min function to locate and output the lowest value. In this case, the math.min function should output -150. Let's test this in our web browser to see if it works. We can see in our web browser that -150 is in fact outputted. But what if we wanted to see the maximum value listed in this sequence of numbers? In that case, all we have to do is update min to max, save the file, and refresh. Now we have the highest value in that list, 600. We can round decimal numbers to the nearest integer using the math.round function. In this example, we use the math.round function to round the value of 15.4 to the nearest integer. Since the value after the decimal is below 0.5, the number will be rounded to 15. We can test this in our web browser to confirm the results. This is the output in our web browser, and we can see that 15.4 has been rounded to 15. Now if we update the value to 15.6, the number will be rounded to 16. To specify whether the value should be rounded up or down, we can use the math.ceil or math.floor function. Let's go ahead and specify that we want 15.6 to be rounded down, so we'll change it to math.floor. After saving the file and refreshing the page, we can see that it now rounds down. If we wanted to round it up to 16, we can specify that by putting math.ceil. And once we refresh the web browser, we can see that the value has now been rounded up to 16. JavaScript arrays are used to store multiple values in a single variable. In this example, we've created an array variable called fruits and stored 6 values into it. Each value contains the name of a fruit. The 6 values we have are apple, orange, pear, grape, tangerine, and mango. In order to output a specific value in the array, we can refer to it using an index number. The index number starts with 0. The first item in the array is identified by the index number 0, in this case, apple. If the index number was 1, we would be referencing orange, and so on. Since we've used an index number of 0, when we preview this in our web browser, we'll see that the word apple is displayed. This is the first item in the array. If we change the index number to 3, we'll see that the word displayed in our web browser changes to grape. And that's how we reference individual items in the array. In the situation where we wanted to display the number of items in the array, so for example here we have 6 items, we can use the length property. We've used the length property before. And when we save the file and refresh the page, we can see that the number 6 has been outputted because there are 6 items in the array. There are many ways that the values in an array can be outputted. We can output each value in the array by using the toString method. To do so, simply type in toString and an open and close bracket. I'll save the file and we'll preview this in our web browser. And we can see here that each item in the array has been outputted. You'll also notice that each value is separated by a comma. If you want to specify the separator, use the join method. In this case, we'll specify that we want an asterisk as the separator. Keep in mind that the asterisk is contained within an open and closed quotation, and we've also included an individual space before and after the asterisk. So after you've saved your file, refresh your web browser, and you'll see that the separator has now changed. We can remove the last element of an array from being outputted by using the pop method. In this case, the last element is mango. This will no longer be presented in our output. As you can see in our web browser, mango is not outputted. In order to remove the first word instead, or the first element, we can use the shift method. Now when we save our file and refresh our web browser, you'll see that mango reappears, but apple has been removed. To add a new element to the end of an array, we can use the push method. In this case, we'll add the word cherry to the very end of our output. And you can see that we now have a new element that has been outputted. To add a new element to the beginning of an array, we can use the unshift method. We can see that the element cherry has now been added to the beginning of the array. Array elements can be changed using the index number. Let's change the first element of our array to kiwi. We'll start off with the name of the array, fruits, and then specify the index number corresponding to the value we want to amend. And that's it. Once we save our file, we can preview it in our web browser. And we can now see that the first value, apple, has been amended to kiwi. If we were to change the index number, let's say to 3, and save our file and refresh, we can see that grape has now changed to kiwi. We can also delete elements in an array using index numbers as well. Let's delete pair from our list of elements. Since pair would have the index number 2, we can type the following. We'll save our file. And in our web browser, we can now see that there is an empty space where pair would have appeared. The splice method can be used to add multiple new items to an array. This method also allows us to specify the position of the new elements and also if any elements should be removed. Let's go through an example to better illustrate this concept. Say we wanted to add 2 fruits, lemon and banana, after the second element in our array, which is orange. To do this, we can type the following. We start with the variable name, and then we create our splice method. The value 2 indicates that we want the new elements to start with an index number of 2. The 0 indicates that we do not want to remove any of the other elements in our array. Once we save our file and preview it in our web browser, we can see that lemon and banana have been added after orange. Lemon does have an index value of 2, so the output is correct. We can sort an array alphabetically using the sort method. This sample script includes an array variable named cars. There are 4 elements in the array: Volvo, Acura, Honda, and Lexus. Let's go ahead and add the sort method into the script to sort the elements alphabetically from A to Z. We start with the variable name, cars, and then enter the sort method. We'll save our file and preview it in our web browser to make sure it worked. We can see here that each array element is now sorted in alphabetical order. We can also reverse sort the elements in an array using the reverse method. To do so, simply type the following line of code into your script. Now when we refresh the page, you'll notice that each element item is in reverse order. We can join 2 arrays using the concat method. In this sample script, we have 2 arrays. one named girls and the other boys. The girls array has 4 elements: Julie, Samantha, Laura, and Jill. The boys array has 5 elements: Bob, Joe, Walt, Sam, and Fred. The third variable is named combined. This variable will store the element values of both arrays using the concat method. To output these values, we can use our getElementById output method. Let's go ahead and preview this file in our web browser to see what the output looks like. Here we can see that the elements of both arrays have been outputted as we intended. When programming in any language, it's very common to create logic that performs different actions based on one or more conditions. JavaScript has a variety of conditional statements that we'll explore in this lesson. We'll be exploring the if, else, and else-if statements. These statements allow us to execute an action contained within a block of code if certain conditions are met. Let's take a look at how this works with a simple example. We'll create a script that converts a student's numerical test score into a letter grade. To keep it simple, we'll assume the test was out of 100 marks. First, we need to define the grading system. Let's say that a score of 0 to 49 equals an F. 50 to 69 equals a D. 70 to 79 equals a C. 80 to 89 equals a B. And 90 to 100 inclusive, equals an A. In order to do this, we need to start by creating our test score variable and assigning a value. We'll call the variable score, and we'll assign a value of 65 for now. Keep in mind that we'll make changes to this score to test our script later on. Next, we'll need to start with our first if statement. If the score is less than 50, we want to output an F. So start by typing if score is less than 50, we will output an F using the document.write method. If the score is greater than 50 but less than 70, we want to output a D. Since we're adding a condition to our original if statement, we must start this condition with the else if statement. I'll copy this else if statement because we're going to create a few others. So the next one we need is if the score is greater than 70 but less than 80, we want to output a C. This is for if the score is greater than 80 but less than 90, we'll output a B. And if the score is greater than 90 or equal to 100, we want to output an A. The last thing we want to do is if the score is anything above 100, we need to display an error message indicating that the score must be less than 100 because the exam was out of 100 marks. For this, we'll use the else statement. The else statement instructs the script on what to do if none of the preceding conditions have been met. And now we'll go ahead and save this file and preview it in our web browser. So here we have D that has been outputted because our current score, we've set it to 65. Now that is greater than 50 and less than 70. So if we were to change our score, let's go ahead and change the score to 81. And in this case, it correctly outputs a B because that's over 80 but less than 90. Now let's see what will happen if we create a score above 100. Okay, so our else statement is working. The score must be less than 100. And so you can go ahead and play with that, but that's basically how the if, else if, and else statements work, also known as conditional statements. Comparison operators are used to compare the equality or difference between variables or values. There are several comparison operators that can be used in JavaScript. This chart provides an overview of each one. We'll go through a few of them to demonstrate how they work. In this test script, we've created a variable and assigned it a value of 6. We'll use the getElementById method to output a true or false result when using different comparison operators to compare our variable value with another value. Let's start with our equal to operator. Let's test to see if our variable value is equal to 8. We know that this is not the case, so our script should output the word false when we test it in our web browser. So I'll save this file and just test it in the browser. And we can see that it does in fact output the word false. If we were to change the value to 6, then and refresh our web browser, the output is true because our variable value x is in fact equal to 6. We can use the not equal operator to see if our variable is not equal to 10, for example. This is the symbol for not equal. We'll update the 6 to 10. So we know that our variable value 6 is not equal to 10. So when we test this in our web browser, it should display true, which it does. Now if we were to change this to 6, it should display false because our variable value is in fact equal to 6. You can test out the remaining comparison operators and see what the outcome produces. The Boolean function can be used to find out if an expression or variable is true. As a general rule, everything with a real value is true. This includes both numerical and string data. Anything without a real value is false. Let's take a look at an example. In this script, we have 7 variables declared, B1 to B7. Each variable uses the Boolean function to test whether a specified value is true. Using the getElementById method, we can output the data. Let's take a look at this page in our web browser to see the results. We can see in our browser that all the numbers, including 80, 2.6, -10, are true. The same goes for variable b6, which contained the equation. The strings included in variable b4 and b5 are also true. The last variable, variable b7, which contained the value 0, is false. A for loop allows us to execute a block of code repeatedly. They come in handy if you want the same code to run over and over again, each time with a different value. Let's take a look at an example to illustrate how for loops work. The objective of the for loop we create will be to output the values 0 to 10 on separate lines in our HTML document, as shown here. So let's go ahead and get started. The first thing we need to do is declare the variable that will contain our initial values. We'll call this variable count. Now we can create our for loop. To do so, type the following block of code. And that's it. In this block of code, we first established the for loop. Next, we've defined the parameters of the for loop. We've set the initial value for variable count to 0. We then instruct the script that the value should increment by 1 up to a maximum of 10. The document.write functions simply output each value in the loop separated by a line break. So let's go ahead and save this file and test it in our web browser to make sure it works. And we can see here that each value is outputted onto a separate line, just as we instructed it to do. Now let's see what would happen if we were to change the value of our count variable to a different value. I'll change it to 3, save the file, and refresh. Now we can see that our initial value starts at 3 and increments up to 10. We can increase our maximum value by changing 10 to 20, for example. And now it'll keep looping until it reaches 20 instead of 10. The JavaScript for in loop loops through the properties of an object. In this example script, we've created an object variable called person. The object contains 3 elements: fname, lname, and age. The for in loop will loop through each item of the object and output the data. Let's go ahead and test this in our web browser to see the result. We can see that each item in the object has been outputted: John Smith and 30. The while loop will loop through a block of code as long as a specified condition is met. Let's take a look at an example. We'll create a script that outputs the values of a variable as long as the value does not exceed 20. We will start by creating a variable to store our initial value. We'll call this variable I. We'll assign the value 0 to this variable. Now we can create our while loop. Here, we've instructed our script to output the value of I as long as the value does not exceed 20. The while loop will loop over and over 19 times in this case. Each time it will output the value of I started at 0 and incremented by 1. So let's go ahead and save this file and preview it in our web browser. So we can see that the value starts at 0, that's the initial value of I, and it's incremented by 1 up until 19. We can modify our script if we adjust our maximum value to 40. We can now see that it goes up to 39. We can also adjust the value of I if we wanted to start the incrementing at 5. And that is how the while loop works. The do-while loop is a variation of the while loop. A do-while loop will always execute the entire code block once before checking if a condition is met. If the condition is met after the first pass, it will then loop the code block as long as the condition remains true. Let's take a look at an example to illustrate this. On this HTML page, we have a JavaScript function that's executed when a button is clicked. We can see the onClick event in our button element that triggers the function named myFunction. The function in our JavaScript tag starts with defining a variable named I with an initial value of 0. Then we have the syntax for our do-while loop. This loop will start by outputting the value of I and incrementing it by 1. It will continue to loop and increment as long as the value of I is less than 10. We can see this condition defined in our while parameter. Let's click the button to see the result. We can see the loop starts at 0 because that's the initial value of I. The value of I is then incremented. It is incremented until the value of I reaches 9, which is less than 10. Now let's see what would happen if we were to change the initial value of I to 11. We can see that the output is now 11. This is because the loop executed once, but it does not execute again because this condition is no longer met after the first pass. We can use the JavaScript break and continue statements to either exit a loop or skip an iteration of a loop. Let's start with the break statement. In this example, we've declared a variable I. Next, we have a for loop that sets the initial value of I to 0 and defines our loop to execute as long as I remains under 10. So from 0 to 9. We then have an if statement that will stop the loop if the value of I hits 3. And that's what the break statement allows us to do. In our web browser, we can confirm that the loop did stop when I hits 3. You can see it, we only have the value 0, 1, and 2 outputted. If we replace the break statement with a continue statement, we can skip an iteration of the loop when the value is equal to 3. The loop will continue as normal after the skipped iteration. So you can see that we go to 0, 1, 2, 3 is skipped, and then the loop continues onward until the value 9. We can use JavaScript functions to create blocks of code that perform particular tasks when called upon. Let's take a look at an example to illustrate how functions work. Here in our script tags, we've defined a function called myFunction. This function has two parameters, a and b. You can call your function anything you like. The name can contain letters, digits, underscores, and dollar signs. The code to be executed inside the function is placed within a set of curly brackets. In this case, the function is meant to output the value of a multiplied by b. To do this, we use a return statement. It's important to note that a function will stop executing once it reaches the return statement. The values of a and b are contained in our inner HTML function, in this case 8 and 2. These values are known as arguments. They define the values of the parameters inside the function, in this case a and b. And you can see that we've referred back to the function name as well before inserting our arguments in the brackets. We can see in our web browser that the arithmetic was performed, as 8 times 2 is 16. One of the key benefits of functions is they can be used as many times as needed with different arguments to produce different results. For example, to multiply different values in place of 8 and 2, simply update the arguments. Now we're multiplying 6 and 5, and you can see that the output is correct, 30. We can use different types of events in our HTML document to execute JavaScript code. There are many different types of events, but some common events include mouse clicks, mouse overs, mouse out, key down, and document load. Let's take a look at a basic on-click event. In our sample HTML file, we have a button element that will display the time when clicked. In this case, the event is the click, and the function that is triggered is the date function. We've used the inner HTML statement to display the output. We can see in our web browser when I click the time button, the date is displayed, the date and time. We can change on click to on mouse over. And now the function will be triggered when I hover my mouse over the button. I don't need to click. If we change it to on mouse out, the date will be displayed once my mouse is out of the button area. Now that we have a better understanding of how JavaScript works, it would be a good time to work on a couple of projects. First, we'll start with a simple script that changes the background color of a web page every time the page is refreshed. We can see the end result in this example. Every time I press the refresh button, we can see that the background color is changing. So let's go ahead and get started. The first thing you'll need to do is set up your basic HTML page structure and save the file on your computer. Next, create your script tags inside the body tags. Inside our script, we need to define a variable that stores all the possible background colors in an array. So here we have a variable called bgcolor, and it stores 8 values inside an array, and each value is a hex code representing a different color. You can use the same colors we've used or different colors if you like. Now we'll need to create the JavaScript statement that will randomly select one of the colors in our array and apply it as the background color each time the page is refreshed. So to do that, we've used the document body style property and set it to a randomized value in the bgcolor array index. The value of the index is derived by multiplying a random value between 0 and 1, and that's done using the math.random statement. We've multiplied it by the length of the array, which is 8. We then use the math.floor statement to round the value to the nearest whole number. So this gives us the value of our index number in the bgcolor array. And each time it's going to be different. So that means each time the background color will be different as well. And that's it for the script. Once you're done, just save the file and preview it in your web browser.